Hi there, and welcome to this lesson on Pure Mathematics 3. In this lesson, we're looking at how you use trigonometric identities that you already know to prove other more complex trigonometric identities. And in this lesson, we'll be using the addition formulae and the double angle formulae. So you'll need to remember for sine, what sine A plus B is sine A minus B, sine 2A. Same thing for cos, and same thing for tan. If you don't already have those written down, then I'll pause the video at this point and very quickly make a copy of them. Okay, first example. Using sine 2a is equal to 2 sine A cos A, prove that 2 sine theta over 2 cos theta over 2 times by cos theta is the same as a half sine 2 theta. Now I'll let you have a go at this yourself first. The only help I'll give you before you start is we'll be using the substitution in the double angle formula that A is equal to theta over 2. But have a go yourself, pause the video, and then come back to me when you're ready. Okay, let's have a look at this. So if you substitute in A equals theta over 2, A becomes theta over 2, and 2A is double theta over 2, which is just theta. So sine theta equals 2 sine theta over 2 times cos theta over 2. To prove the identity, we'll start either with the left-hand side or the right-hand side. In this case, it's easier to start with the left-hand side, which is 2 sine theta over 2 cos theta over 2 cos theta. And immediately you can see that the beginning of this expression is exactly the same as sine theta from the identity. So we can substitute in for sine theta. And the left-hand side just becomes sine theta times by cos theta. Sine theta cos theta is virtually identical to the right-hand side of the double angle formula for sine again. The only difference is the 2. So we'll need to divide the other side by 2, and sine theta cos theta will equal a half of sine 2 theta. And that's the right-hand side. So we started with the left-hand side, we've manipulated it, it's only taken a few steps, and we've ended up with the right-hand side. That's the question done. Okay, example 2, prove that 1 plus cos 4 theta is the same as 2 cos squared 2 theta. And again on this question, you're told which identity you have to use. It's the double angle formula for cosine. I'll let you have a go at this yourself. Pause the video, come back to me when you're ready. Okay, let's have a look. So the left-hand side this time is 1 plus cos 4 theta. Now cos 2a is 2 cos squared a minus 1. Cos 4 theta, well that's double that. So cos 4 theta will be the same as 2 cos squared 2 theta minus 1. 1 and the minus 1 will cancel with each other, just giving us 2 cos squared theta, 2 theta. And again, we've arrived straight away at what we've been asked to arrive at. So we started with the left-hand side, we've manipulated it, and we've shown that it is equal to the right-hand side. That's example 2 done. Example 3, prove that tan 2 theta is equal to 2 divided by cot theta minus tan theta. Now you haven't been told which identity to use here, but I think you'd be able to guess. There's one step in the middle which is a little bit hard to guess, but I'll let you have a go yourself first. So pause the video, have a go, and come back to me when you're ready. Okay, let's have a look at this. So as soon as you see tan 2 theta, it's got to be possible that you're using the identity for tan 2a, which is 2 tan a divided by 1 minus tan squared a. Now looking at the left-hand side is tan 2 theta. Well, tan 2 theta, just using the identity straight away, is equal to 2 tan theta divided by 1 minus tan squared theta. It's this next step which is not obvious, and if you manage to guess it yourself, then you did well. But the best way forwards from here is to divide this fraction, the top of it and the bottom of it, the numerator and the denominator, by tan theta. So we're going to divide the top of this fraction by tan theta and the bottom of this fraction by tan theta. And that gives us tan 2 theta is equal to 2. And on the bottom, we'll have 1 divided by tan theta minus tan theta. So we've just divided all three terms by tan theta. 1 divided by tan theta is cot theta. So again, all we have to do is change 1 over tan theta into cot theta, and we have arrived at the answer that we want. We've started with the left-hand side, we've manipulated the left-hand side, and we have shown that it equals the right-hand side. That's the question done. Question 4. Prove that root 3 cos 4 theta plus sine 4 theta is identical to 2 cos 4 theta minus pi by 6. Now you're not told which trig identity you need to use. Have a look at the right-hand side, the cos 4 theta minus pi by 6. That's where the clue is as to which identity you should be using. But I'll let you have a go. Pause the video, try and do this, and then come back to me when you're ready. Okay, let's have a look. Now, I said have a look at this function on the right-hand side, which has the form cos A minus B. So the obvious identity to try and use is the one that has that form, the cosine of A minus B, which is cos A cos B plus sine A sine B. Then breaking up this term on the right-hand side. So this question is different from the other three we've done. The other three we've started with the left-hand side, and we've changed it until it equals the right-hand side. We're not going to do that this time. It's a little bit easier if we start with the right-hand side and we change it until it becomes the left-hand side. So the right-hand side is 2 cos 4 theta minus pi by 6. Using cos A minus B, that splits up into 2 times cos 4 theta cos pi by 6 plus sine 4 theta sine pi by 6. These are exact values that we can find, the cosine of 30 degrees and the sine of 30 degrees. Cosine of 30 is root 3 over 2, the sine of 30 is a half, and I brought the 2 inside the brackets there. Now, 2 times root 3 over 2, the 2's will cancel, we'll just have root 3 times cos 4 theta. 2 times a half is just 1. So when we multiply these numbers together, we do just get root 3 cos 4 theta plus sine 4 theta, which is the left-hand side. So we started with the right-hand side, we've manipulated it, and we've changed it until it equals the left-hand side. At that point, the question is done. Okay, if you have the textbook, turn to page 91 and have a go at exercise 4F. This is the end of the lesson. But thank you very much for listening, and cheerio.